So please welcome Johnny.
I guess my data ingestion skills didn't work very well. The message was completely different, but let's roll with that. So I do have eyes, yes, but come and talk to me after the session about that. Okay. Moving on. So today I'm gonna. It's quite fortunate that Zdeněk had a session before me, because I'm going to jump on quite a few topics that he touched previously in the slides. So basically today I thought, it's Christmas time, and everyone's buying gifts, so we're all out of money. So I'm going to maybe teach you guys how to save a bit of money by using some cloud resources. How to effectively process data in the cloud, right? So because there's always an ongoing myth that the public clouds are very expensive, which is true, but there are ways to sort of like push that pricing down a bit, right? So plus you can maybe get some pretty nice resources, process your data much quicker. So this is what it's about today. So just how many of you guys heard about Gauss logarithmic as a company? Wow. All right, we're spreading the word. I'm slightly doing a bit of marketing in Gauss, so that's good. It looks like we're being successful. So in general, the punchline is that we try to create value out of data, for companies, people who are trying to solve very difficult problems. The key word here is value, right? So it's not just about providing the best compute, the solution to the answer, but to do it effectively at a reasonable price. So my main job as a big data architect, right, which is your official job title, is to sort of design these solutions, right, and we do it end to end, and we try to make it as effective as possible. We have some preferred technologies, so we work, for instance, quite a lot with Cloudera, right? But obviously we're open to creating all sorts of weird mixes of technologies that we like and find useful. Anyone from the telco space? Maybe you can talk to me later. I've been working there for about 10 years, so I'm especially interested in anyone who's processing data from operators or ISPs. So my first question to the audience, as usual, there's always a question, right? Where do you process your data? Azure, right? So we got one cloud here.
We have our own data center.
Right, you have your own data center. How much did it cost?
1 billion Czech crowns, I think.
Right, very nice, very nice. Anyone else have a data center? Small, large? All right. Few people on the laptop, right? So there are various. I mean, the partners and customers that we mostly work with are, let's say, almost a majority of them are working on either private clouds or on-premise infrastructure, right? There's not been a large push to the cloud, right? For obvious reasons. So the reasons why are various, right? But in general, the on-premise infrastructure is still, quite hefty in terms of your TCO, right? So there's plenty of people you need, to maintain your systems. There's plenty of hardware which has to be bought in, bought out. This is a line which actually came out a couple of days ago, right, and caught my eye, right? That 33% of enterprises will take the data lakes offline, right? It's a very interesting shift what's happening, right? Even if do you guys know the Strata conference, right? It used to be called Strata and Hadoop World, right? And now it's just called Strata Conference, right? Which is very interesting, right? So Hadoop and these kind of technologies which have been predominantly deployed on premise, right, are suddenly sort of like trying fading away, right? Because the cloud is slowly coming back. So since we talked about Hadoop and these kind of infrastructures, right? So just to give you a perspective, so an entry cost for a company is about this much, right? If you want a production-ready, secure, compliance, all sorts of enterprise features available, cluster to process your big data, this is probably what you pay. Right? It's a lot of money, especially for companies here in the Czech Republic and surrounding countries. Now, the question is if we can do it in a better way, right? So cloud has been in the past quite some, there have been some myths, there have been some problems, and I found a table which sort of like explains where the problems, or where the customer sees where the problems are, right? So this is a research from a company called RightScale. When you're a cloud beginner, so your main problem or your main concern is security, right? So Google will be scanning your data, right? Amazon will be scanning your data. There are these perceptions there which aren't, I would say, really true, but you never know. But security is a major concern. But then suddenly you can see that the security problem, when people start to use the cloud a bit more, suddenly shifts much more downwards, right? Then eventually comes into fourth place. But notice what goes up into the ranks, right? So those people who are more cloud focused are the major challenge is managing costs. So if you were to take two things out of today's presentation, I want you to take out these two words, right? So what the cloud is really about. So that's cost, flexibility. So cost, flexibility, right? So it's never been, more simpler to launch instances today. It's never been, cheaper to process data in the cloud. Right? This is really what's happening. So let's make a short model, right? So typically, back in my day when I was a junior big data architect, I don't know if I was really called junior, but early days in my career, and someone would ask me to build a distributed system, be it Hadoop, be it any sort of like master worker architecture type of system using replication, sharding, whatever. I would have built it out the same way as I would have done an on-premise installation, right? So whatever I would do on physical hardware, I would have done in the cloud, right? Through time, you'll find out that this is not a great idea. So this typical cluster, so this model cluster would give you about 32 CPU cores, 120 gigabytes RAM. If you have a replication factor of 3, you'll probably get around 6 terabytes of storage space available in that cluster, right? So the question is, what would this cost you? So that minimum spec would probably get you to this amount in the cloud on a monthly basis. So this amount you would have to pay in Czech crowns if your conversion calculation in your head doesn't work very quickly, then I put the Czech price. So this you would have to pay. This is specifically Amazon. You have to pay Amazon this every month, right? But if you would take the same spec as an expected production-ready cluster, so maybe what Cloudera or Hortonworks recommend, so it's usually some 24 cores per server, 128 gigabytes of RAM, and these kind of things, 10 gigabit Ethernet cards. This is roughly what you would pay. So this is what your company would have to pull out in their budgets every single month. So there are a lot of problems that we can solve today, right? So I tried to keep it, simple and short, and I've created this sort of checklist which we'll go through individually, and we'll try to see if we can save some costs in terms of the cloud and use some resources which are there, plus some techniques to lower the price as much as possible, right? So the first one that we'll go through is utilizing an object store. Who knows what an object store is? Okay, few people, object store. So object store is sort of a form of storage in the cloud that you can store objects in, right? But it is that, right? But so to give an example of an object, it could be a file, right? It could be a picture, right? Something which is basically a blob format, right? So the thing about these storages right now is how much would you say it would cost you to store 1 gigabyte in such a storage.
For how long?
Well, let's say per month, right? Per month cost. 50 cents?
75 cents?
75 cents, right? It's about 20 cents right now. Right, so for example, S3 as an object store is 0.0245 USD. So about 20 cents. Right? Really cheap.
0.02 is 2 cents.
Sorry. 0.02. So 2 cents actually, yes. Yeah.
It's a huge difference.
It's a huge difference, yes. Huge difference. Right? So 0.02. We can look it up in the AWS calculator. So AWS, for example, has a calculator. Microsoft Azure has also a calculator. It's really cheap. So a terabyte would set you back, correct me if I'm wrong, right? So a terabyte would set you back probably about, no, it has to be 20 cents. So a terabyte is around $20.
That's 2 cents.
2 cents. Right. I wasn't good at maths. So the key thing is really cheap. So Hadoop or HDFS, the cost of HDFS, if you add a third of that price on top of that, it's much more expensive, or much more, slightly more expensive. So object store. Another thing I want to point out today is that utilization, right? You should only pay for what you use, right? And this is jumping on that flow chart basically that Danny was showing today. Yeah, he's nodding his head. He knows what I'm talking about. So the problem is that most clusters which are on premise run 24/7 but are utilized by a very, very little percentage, right? Usually it's somewhere in between, on average, 5 to 10%, right? So if you look at the fixed lines, these are the average hourly usage values, right? So you can see that mostly the peaks are during the evening periods where there are nightly workload, some heavy lifting being done, and otherwise the cluster, which this is by the way a 10-node Cloudera Hadoop, and during the day, even when people are using it and doing all of their queries and things like that, it's pretty underutilized, right? So pretty much waste of space, electricity. When if you would shut it down, maybe you would save some money. But in the cloud, you can actually do that, right? So the key point is that most companies don't need a full-scale cluster 24/7. So you have to figure out what is your ideal usage time in the cloud. So next one is discounts. Most cloud providers offer some form of discount, right? Usually when I ask about this, most people, when I talk to companies, most companies don't really know this too much, right? So there are 3 types of instances, for example, in Amazon and in Google and Microsoft Azure is very similar. So you have on-demand instances, right? So this is the normal functionality. So you spin up an EC2 instance in Amazon, and you pay some sort of price, right? In most cases, you're looking at the on-demand pricing, right? So if you imagine that Amazon has a data center, he has some capacity there. So this is capacity which is always available to all of the users who come there. Now, there are some reserved instances, right? So the difference between on-demand and reserved is not, in form of capacity or compute. It's mainly business reasons behind that. So if you make a commitment of 1 to 3 years, you'll get a very good discount, right? So you'll pay, usually it's, right now I think it's like 56% per different instance. So you can, if you know you're going to be using that system for the next year, then don't pay the on-demand price, just pay half price, right? And the third one is spot, right? So there is some capacity which also in that data center is reserved, just a bit extra, right? A threshold that sort of have there, you know, in case of anything that happens, right? But they still want to utilize that space, but in case on-demand goes up, they want to reclaim that space very quickly, right? So there's a form, the price in the spot space fluctuates, right? So maybe during the day it's a bit higher, during the evenings it's a bit more down, right? But usually you're around 80% of the on-demand price, which is a very large discount. Now, this is all of these. If you think you have a fault-tolerant system, right? Then a good mix is maybe a mix of reserved and spot, right? So you will have a bit of both there, right? But you have to figure out a couple of things, right? So you have to know exactly how your system works. So if you do more spot than reserved, right, and they take all your spot instances, your system has to survive that in some way. So if your system is about replicating data, when it loses a physical server, then you have to have space on the reserved instances to replicate that data back, right? So there are a couple of things that you have to keep in mind, but a combination can be used for distributed systems. Now, just to show you, you know, that I'm not lying, this is taken from a tool in AWS, which shows basically some advisory details about spot pricing. So typically I like to use the M4 2X large, which is 8 virtual CPUs, 32 gigabytes of RAM if you don't see it in the back. And currently it's 0.1385 US dollars per hour. Do the math in your head. I'm not going to do that because I just, it didn't work the first time, so I'm not going to try it again. So we talked about discount. And now, probably you're wondering how to put all of this together, right? So how do you optimize the architecture in a way for all of this to somehow work together? Now, obviously there will be some data. So let's first talk about maybe the data part. So there will be some data which is constantly coming into your system, right? So, you know, we mostly do real time. I mean, it's how we roll. And you can collect, you know, typically in the cloud, you can directly collect some types of data which is more suitable, right? So typically, you know, your web click stream, IoT, payments, transactions, right? Everything that flies in very quickly. So this real-time system here is going to be here ready 24/7, right? You can have a Kafka there, you can have Flink, you can have whatever be it, just to process data. And your, let's say, persistent storage here is the object store, right? Store it there, it's cheap. Whenever you need to use it, spin it up again, right? If users need to come and query the data, spin up some SQL engine or other types of compute which they can use. You can use Lambda, you can use Athena, Impala, and users will be able to access that processed data from the real-time stream very quickly. Now, but sometimes you have workloads which you want to work and need some more compute, right? So typically, machine learning workloads, right? More difficult transformations, enrichment when you need to get more data together. Now, here in this green dashed box, we have a temporary cluster, right? So the whole idea of running these workloads, like I said, you utilize it only when you use it, is to spin up a cluster anytime you need to process information. It is possible to do. Amazon won't ban you to do that. On the other hand, they want you to use their services, right? So typically, I'm a client. I have a job which I want to process. I submit that process into some form of automation. We'll talk about these two tools. These are my preferred tools, right? But it can be any type of automation to spin up a cluster and submit that job into that processing, right? The processing goes through. Now you can see I've got a mix of instance types, right? So I have a cluster which is a bit more resilient on the first side. So I have on-demand instances. I can use reserved instances if I need to run it longer, but typically I would use probably on-demand, and then the additional compute power will be filled out with spot instances, right? And I can use then as many spot instances as I have available. Now, the reason why I want to use those spot instances is that with that extra compute power, I am very likely to finish that compute much more quicker. That means I'm using less time in that cloud, which means I'll pay less. Right? So that's the whole idea. And once I'm finished with that job, obviously my goal is to destroy this temporary cluster. So I transfer the data back to S3. Now you might ask yourself, isn't that slow? Well, it's within, if you keep it within the same region in AWS or in Azure, right, their pipelines are fast. Right, you can try yourself at the end of the day, but it's extremely fast to transfer from instance to S3. You might have clients who don't really want to put all of their data in the cloud, right? But you still need to do some sort of cross-validation, pairing of users and things like that. So another way to do it is basically to have a mechanism to extract that data, and we have a specialized tool for that, which we built ourselves, to take this and basically anonymize, tokenize, whatever you need to do to prepare that information and put it into S3, and the same mechanism can take that data from S3 back into the local environment, right? You have to be a bit careful about, how often you use it, so be smart here. So don't, throw raw logs just for the fact that you want to process them in S3. Prepare the data that you need, which will enrich the information that you're trying to get. So that was the architecture. So how much of a difference do we have right now? So I did a model here. So let's say to the extreme, more or less, 8 hours compute, right? Typically your compute hour will be something between 2, 3, maybe 4, right? If you count the amount of seconds, maybe you're doing a query and just put it together. You'll probably get to 2 or 3 hours. But if we really had a very intensive cluster with 8 hours constant compute running on top of that, so this is the sort of pricing. So we have the real-time part here. You'll get maybe to some 400 USD, right? For if you just have 3 instances, maybe 3 Kafkas there, something like that. Then we have the on-demand instances, 8 hours running, some volumes for some extra storage space if needed, and then we have 3 support instances. So from the previous picture that we saw, it's practically that temporary cluster, right? If you want to know what instances I'm using usually the M4 type of instances, which is usually 16 to 32 gigs of RAM, right? So that's the total price. So we are much lower than 3,000. I mean, it's not something that you would pull out of your pocket at the end of the day, right? But it's still less expensive, right? And depending on what technology you use for the compute, so maybe if you're just using Apache Spark and you just need to put that stuff in memory and compute that there and just store it out, then you maybe don't even need the EBS volume. So you can, maybe here, yes, but you can cross it out from there and there, so you can subtract another 300 and someone do the math. I'm terrible at this. So this is the reduction. But this doesn't come easy if you don't have automation in place, right? So I've got 2 specific tools. You saw them before. These tools I like because I've sort of learned to use them. So one tool that we've been using for certain automation is Terraform. The advantage of Terraform is that it gives you a lot of flexibility on what you want to do, right? So Terraform, you provide some sort of configuration where you say what provider you want to use, you say what instance types you want to run. If you know a bit of Ruby code, you can do loops there and just spin up infinite clusters. And then you have plenty of provisioning options, right? But the main advantage here, I believe, is if you have some type of configuration, it's quite easy to port that configuration onto other cloud providers. So if you're fed up with Amazon, you can start using Azure, or maybe even OpenStack, right? If you have enough compute available. Another tool I like using, which is quite new, obviously from the CloudOps family, because like I said, we've worked with them quite closely. So they have a tool called CloudOps, which is predominantly built for enterprises. So those type of companies who don't really want to spend too money on the pipelines, right, on the hardware, just getting people there and everything. So this is a fully managed cluster from their side. So what you just see is an interface or an API which enables you to submit your jobs or work or whatever it is, right? You can pass classes, jars, Scala, Python. 3 types of services are currently now supported. So Spark, version 2, I forgot to write that, MapReduce, if anyone is still writing in MapReduce, Hive, and it also has support for Spot instances. So in Spot instances, you can say if there are Spot instances available for I don't know, 20 cents, right, in my pool, then he'll first go to these Spot instances and launch them up and use them before he starts using any on-demand instances. This is quite interesting, it also supports pre-built images. So you can actually create an image, an AMI, put all your software there, and load it up to Amazon, and when it starts launching the cluster, all your software will be already ready for usage, right, under it. So we've crossed out possibly everything right now. So that's basically it for me. So do more with your data, save money. Yes, go ahead.
So the last slides, how is that different from Amazon EMR?
So EMR is basically Amazon services. So yes, EMR is a very similar service where you use basically MapReduce protocol to do your work. So you can use EMR, of course, right? So it's a very similar service. You can use Databricks. They have right now a very similar service for Spark. It's not really about the tools today.
I was just curious, like, why would you, other than you very closely work with CloudOps, why would you recommend using Altus rather than just directly EMR?
Well, it allows you more basically flexibility from a single interface, right? So typically you would have a mix, right? So someone would be doing some Spark, someone would be maybe just some simplified code. You maybe have transformations in Hive, which some of our customers do quite a lot because they may not have, let's say, the programming skills, right, to do different type of workloads. So it gives flexibility. It's very similar to EMR from the sense that the customer cluster is fully managed, right? So that's probably the main advantage why you maybe use it then, opposed to a Lambda or opposed to Terraform as a tool. More questions? Go ahead.
Actually, I never heard about someone who went from Amazon to Azure. did it happen? Is there a reason to do that?
Yeah, well,
I heard those. I heard about a lot of people who started with Azure, for example, because now you have free credits and because you are starting company, whatever. And then after it expired, they went to the US. Is there also the arrow pointing the other way?
Well, that's always the I would say the problem of how much are you rooted into Amazon's software, for example, right? So Amazon does a lot of stuff proprietary. Right, so obviously if you start talking to them as a company, then they want you to use Amaur, they want you to use Lambda, they want you to use all this stuff, right? And probably getting out of that is a bit more difficult, right? So maybe one of the other advantages of Altus is that you can switch there just with a basically click of a button. So you want to use Amazon, you just use Azure, right? But again, it depends on how you're routed. So if we take the next example, then they've got other services there which are running. So it's not just a simple click. But from the data processing perspective, there are possibilities to do that, right? So you maybe get a better deal. Your company's big, you get a better deal from Microsoft, so you'll get a much different discount. If I can, yeah. Sorry, go ahead.
With the spot service, do you get some announcement that your machine is going to be killed, or
yes.
is it just killed?
Yes, you get an announcement, right? You get an announcement. You can set notifications to different types of channels. Mm-hmm. So it's usually not very long. It's like 5 minutes. so be prepared.
For things like automated testing.
Yeah, well, if it kills your cluster at the end of the day, then and your cluster is resilient enough, then you shouldn't care, really, right? So that was the message. Right? So build a cluster which is resilient, which can withstand these problems or these cutoffs. Yes.
Yeah, my question was sort of similar regarding these spot instances. Actually, how stable it is? How often does it change? Because for some cases, like you mentioned Spark, right? Mm-hmm. It's quite big infrastructure. Yeah. So it takes some time to instantiate the whole processing solution. So if the spot instances changes like every minute, it isn't really usable. So how stable it actually is?
Oh well, you basically enter a threshold, basically, which you're happy with, right? So you don't buy the actual price. You tell which price you want to pay, right? So basically they'll kick out everyone else who put less before they kick out you. Right? So it's business. It's a bit of alchemy to find the right level. So whatever works with your budget at the end of the day, right? And then the number of instances. And then it's based on mainly regions. So different regions have different usage of these spot instances. So in Europe, we're quite okay. So if you use, my example here was Frankfurt, then that's maybe right now not a very frequently used data center, and it's not been built that long ago, so they've got plenty of capacity. But somewhere in the US, maybe New York and these places, it's a bit more congested, right? And time of the day. So if you're working with workloads that you're training the model or something, and it's going to take a couple of hours, then you have two options. So either run it on the instances you want in the evening, or get much stronger instances, right? So usually the very strong instances like 200 gigs of RAM and tens of CPU cores are not very frequently taken by people, right? So you have to calculate if maybe that $1 per hour is enough for you. So you buy 4 instances, you pay $4 an hour. I can afford 4 instances.
Okay.
One more question.
If I may answer that question, from our experience, the spots go down like 6 times a year with our setting. So I don't know exactly how I set up the threshold, but it's really few times a year when everything sort of goes down because the spots are there. So it's not that a big problem.
Yeah. And usually, like when you subscribe to Amazon or Azure or wherever, you always have a cap on instances, right? So anytime you want to use something that's extensive, you always have to ask them to increase your instance level. They probably don't want people mining the Bitcoin and things like that. So. If they pay for it. if they get Bitcoin. Right.
Okay.
More questions?
So, thank you very much. Thank you very much.